Today we are going to examine a natural parabola formed by tossing a ball straight up into the air and letting it fall. Then we'll use our formula to create a function for this parabola. Note that when the ball hits the ground, its height is 0. The height of a ball thrown directly up at any time t can be approximated by this formula, which is the function of a parabola, where t is the time in seconds, h naught is the height of the ball where the ball starts, or the initial height, v naught is how fast the ball is thrown, the initial velocity, in feet per second. 1.87 seconds to the ground, 1.2 seconds to the ground, 1.25 seconds to the ground. So here we have our 3 times that were recorded from our experiment when the ball hit the ground, and we're going to average these together. So here we are averaging our 3 times that we recorded from our experiment, adding them together and dividing by 3 to come up with an average of 1.44 seconds, and that will be the x-coordinate of our x-intercept on our graph. Before we plug in our time, we need to plug in an initial height for our formula. This height was arrived at by measuring the distance from my hand in a seated position to the ground with a yardstick. So our initial height is 30 inches or 2.5 feet. Now we're going to plug in our average time. This is the time when the ball hit the ground. So the height when the ball hits the ground is 0. So we can set f of 1.44 equal to 0. And this is the x-intercept of our function. Here we have an almost complete quadratic function. We have our initial height. We have an average time when the height was 0. The only thing we're missing is our initial velocity. And now we can use algebra to solve for the initial velocity. So first we're going to combine all of our constants with addition. And then we're going to move our negative 30.6776 over, make it positive. Finally, divide by 1 44/100 to arrive at our initial velocity. So we have an approximate initial velocity of 21.3 feet per second. We're going to plug that value in as our last coefficient in our function, and now we have a complete quadratic function based on our experiment. We have used the program GeoGebra to graph a model of our experiment. You can see our function on the top left. We used x instead of t, but it graphs the parabola, which is a model of our throwing the tennis ball. The y-intercept, you can see 0 and 0.25. That is our initial height. The maximum height of the ball was approximately 9.59 feet, and that occurred at 0.67 seconds. We found this with the extrema function of GeoGebra. You can also clearly see the x-intercept of 1.44 seconds, which was the average time when the ball hit the ground.